and I'm going to go over the material in a certain priority list. The homework assignment is reversed. I'm hoping at least you have gotten started with it. The stuff that we talked about last time should already get you with the outer loop done, because you can check for the word quit. Okay, so you basically just use readline or getLine. Excuse me. You use getLine as a method to get the content of every line from static input until you get one line where the only content on that line is QUIT or in lowercase. Then you can get out of the loop and not reverse QUIT. Okay, when you get QUIT as the input, don't reverse it and print it. Just quit. Just get out of the loop and you're done. Yes.
I tried to refer to your last class video, but it wasn't uploaded.
The last class was not uploaded.
Yeah, 12.1.
Okay. Well, I can stay on this page. Add more video. There we go. So we are talking about the one on Monday?
Yeah, early.
Okay, so that one was probably the late one is not uploaded either, so I'm gonna upload both.
Oh, you have it. I was trying to look for that and it wasn't there. I'm like, oh
no, I need that space to download the imitation game, so I just deleted all of the class videos.
Priorities.
Priorities. Gotta set your priority right. Yes, exactly. Okay, so it's getting uploaded right now, so you guys will have it, momentarily. Okay, so getting back to reverse, the first part, the outer loop, I'm hoping most of you are at least getting started with the outer loop, which is just, getting one line of input at a time, up to 80 characters. If it is only just quit QUIT, you get out of the loop. Okay, so that part I'm hoping you guys are getting. So what we'll do today is to focus on the second part. Okay, how do you reverse a string? Now, obviously, I'm not going to show you exactly how to reverse a string, but I can tell you the procedure that you have to write to reverse the string, and it's not really too involved. Okay, so what you will have to do is to write a procedure or function that has a void return value, and it has to be called exactly str reverse or string reverse. And what it's going to do is it will take three parameters. The first parameter is what is going to store the reversed version of the original string. The second parameter is the original string itself. And then the third parameter is the number of characters that you're supposed to reverse from the second parameter to the first parameter. So this has to be called from the loop. Okay, in other words, if you read a line in and it is not quit, okay, then you have to call string reverse. So this also means that you need two arrays. One array for the line that you're reading in, and then another array to store the reversed version of that line. Okay, because they're not supposed to be the same. And then when you print it out, you're going to use the reversed version and not the original. Are there any questions at this point about what a string reverse is supposed to do? So it's a procedure, it is a function, then you are supposed to kind of make use of this prototype and specify the content or the definition of the subroutine. What we'll do today is not to, I'm not going to write a string reverse for you, but what I will do is I'm going to show you certain things that you can do with strings, particularly looking at a string as an array of characters. And I made a note to myself here under the latest topic, strings in C. And my note to myself is in class demonstration, I want to write these four subroutines so to show you so that you know what kind of code you're dealing with here. Is that okay? So what we'll do is we'll focus on string copy first, and then we'll deal with string and copy because one is the unchecked version that is only it will only stop when the source string encounters a null terminator. The second one, which is string and compare, is going to stop based on the number of characters that you specify as well, on top of encountering a null character. So these two are not exactly the same thing. So what I'll do also is to show you the man page of string copy. Okay, this is just so that you know where you can find some additional information of the function string copy, which is not your program. Okay, string copy is a very standard function in C and C++ programming, and that's why in most Linux environments, if you just say man, which stands for manual, string copy strcpy, it will show you the man page. Okay, it will show you how to use string copy. And right here it says right here the string copy function copies the string pointed to by source, which is actually the second parameter, including the no terminating character, which is also represented as \0, to the buffer pointed to by destination, which is the first parameter. The strings may not overlap, and the destination string DEST must be large enough to receive the copy. Beware of buffer overruns, and so on. Now that really is not a bug of string copy. It is a usually an oversight on the part of the programmer who make use of string copy. All right. Okay. So now that we have talked about what a string is, now in C a string is very special because how do we know where is the end of the content of a string?
It's going to be the enter, the dash, and
The no terminator.
yes.
A character with an ASCII code of 0. So if you declare a string, an array of characters, let's say 4 characters, okay? And let's just say the first character has an ASCII code of A, the second character has an ASCII code of B, ASCII code of C, and ASCII code of D, okay? Where's the end of the string? There's no end, okay? So, okay, so I can show you with a with an actual program, so this will be even better. Okay, so we'll go ahead and write a simple program to illustrate problems they can run into when you're dealing with strings in C. Okay. Okay, I'm going to include IOStream, okay, because this is a C++ class, which also means I need to change the name to overrun.cpp so that it becomes a C++ source file and not a regular C source file. But the problem still exists in C++ because it is not a problem with C or C++. It is a problem related to how a string is terminated and how sometimes you can look at a string and just say, oh, it is just an array of characters. But other times you have to look at it like, okay, but where is the first no terminator in that quote-unquote string? Because that really defines the content of the string. So we'll do some kind of simple examples first that does not have any overrun issues, and then we'll deal with some other code that has an overrun issue. Okay. So we'll go ahead and define our string. We'll just call it str, and let's say it has 4 characters. Okay. And I will initialize each character in the array one by one. The first one is lowercase a, and let's say the second one is lowercase b. The third one is the no terminator. Okay, when you specify the no terminator, you can just use a 0. That is okay. There's no need to use the \0 in double quotes. Excuse me, in single quotes, because you can specify the ASCII code when you put something into a character. So instead of using quote lowercase a quote, I can look up the ASCII code of that character and use that number instead. So they're basically equivalent. This way is just this is just an easy way, so I don't have to look up the ASCII code. Okay. Now I'm going to specify 3 to be the ASCII code of Z, and then I'll do a simple standard C out str, followed by standard end of line, and return 0. So I'm going to increase the font size a little bit. I made it smaller for a previous class, yesterday, because I had a little bit more content to display at the time, but now that I don't have as much content to display, I can make it a little bit larger so that people can read it a little bit easier. Okay, so what do you think is going to print in this case? What is cout going to print for this particular program? Just AB, right? Because the content of a string is terminated by a null character. In other words, whatever you have after the null character doesn't really matter because it is not considered a part of the content of the string. The array of 4 means that we are allocating 4 characters, but out of the 4 characters that we have allocated, only the first 3 are actually meaningful. The first 2 are the ones that are printed, certainly meaningful. The third one is the null terminator, which is also meaningful. But the fourth one is useless, okay? Because it is after the null terminator, so it is not a part of the content. Yes, go ahead.
And I was just saying, I wanted to add that it's also like the end line, so it returns the.
It wraps around the line, it opens a new line. Is there a problem with the code?
No, it's because when I tried to do STD, I forgot to put the STD at the end, and so the end line wouldn't register.
Right.
And so it just looks a little bit different, but I think that's the way to do it.
Yeah, if you use using namespace, then you don't need to specify STD : all the time. Yep.
I was just reviewing arrays before this class. So if we're gonna have A, B, and then string to C instead of a null character, and then Z in the third. So and then display it, it's gonna show A, B, C, Z. But if we put the one in a string and fourth, the bracket 4, string bracket 4, it's gonna be outside of the.
It's going to be outside of the
array.
The array itself. So you're going to be corrupting a byte of something else.
So it's always 1 less than the actual array?
That is correct, because we count from 0. Now when you use this 4 here on line 4, you're basically saying I'm declaring an array of 4 characters. Okay? But because the first character has an index of 0, that means the last one is going to have an index of the total number of characters minus 1, which in this case is 3.
Okay.
Okay? This is a convention used by most programming languages. We start counting from 0, so the last item is the number of items minus 1 in an array. Okay, so this program should not be very surprising. Okay, so we'll go ahead and test it out and make sure that it works the way it's supposed to. So G++, I'm not even going to use a -G because I don't think we have to go through GDB in this case. So we say G++ -O overrun.cpp, and then we just run the program, and it prints AB, end of line, open up a new line for the command prompt, exactly how we envision it should be. Okay, no problem. But the important part is Z is not printed because it is after the null terminator. In other words, the letter Z is not considered to be a part of the string. Okay, or the content that is relevant to us. Are there any questions about this particular test program? It is not overrunning yet, okay? There's no overrun at this point. Are there any questions about this code? I think Mickey first. Yeah.
All right, so since you have the null terminator in your
As the third character, yes.
element of your array, it's stopping there.
Yeah, exactly.
Now, if you had the quotes around it, would it type AB0?
Yes, it would type AB0 and then a Z because I lost my null terminator.
Right. So, but since there was no null terminator found, would it just continue?
Potentially can go on. Okay, potentially can go on. So okay, so here's the second program. The second program, is okay. I cannot remember, how it orders, array versus non-array stuff, but I think the array stuff is, has a lower address. So I'm going to put something into I first. Okay, so I gets 0x, meaning it's a hexadecimal number, and I'll just specify some junk here. Okay, okay, 1, 2, 3, 4. So we do have 4 bytes. Okay, that's good enough. All right. So at this point, if I run the program again, what do you think the program is going to do? Same thing as last time, right? I has nothing to do with the string that we're printing at all, right? Okay, well, let's double check. It doesn't take long to double check on this one. So we'll go ahead and just double check and make sure that the program still prints AB. Not a problem. Is that okay? Now we go ahead and kind of mess up the program, okay? And the way I mess up the program is exactly what you said, okay? Instead of using a 0 without the quotes, which means we're specifying the ASCII code of 0 right now, I'm now specifying the digit 0, which is not corresponding to ASCII 0, okay? The ASCII code of 0 as a digit, as something that is printable, is actually 30 in hexadecimal, which is 48 in decimal, okay? So the way I specify on line 9, I might as well just remove quote 0 quote and just write down 48. It would have done exactly the same thing. Okay? Does everybody understand? When you use the quote, you are basically asking the compiler to fill in the ASCII code of that letter. It would be the same thing if you look up the ASCII table and just type in the number. It would be the same thing. Okay? So now the question is, what is this program going to output? Okay, now that we don't have a null terminator, what do you think cout is going to do? So I can tell you what cout is going to do, but the actual output, we'll have to observe it, okay? What line 13 is going to do when we have the cout is it will start with str, okay? It will start at the very beginning of str, where the subroutine will find the ASCII code of A. Is it a null terminator? Nope. Okay, let's print it. And we'll find the ASCII code of B. Is it a null terminator? Nope. Go ahead and print it. Find the ASCII code of 0. Is that the null terminator? Nope. It will print the 0. Then we'll find Z, which is also not null. It will print it. Have I seen the null terminator yet? Nope. Then it will move on to the next character, whoever, whatever that may be, and ask, is that a null terminator? If it is, then it will stop. If it is not, it's going to print that byte as if it is a character. Yes?
You mean the fourth str is going to print that one?
There's no such thing as the fourth str. It will pretend as if there's a fourth str,
And it prints something that doesn't.
but it does not belong to the actual string, because str, as far as allocation is concerned, has only 4 bytes allocated to it.
So without the null terminator, the cout is going to keep printing as much of the allocated space that's in the string.
It will keep printing until it finds a null terminator in memory space.
Oh.
Yeah. Yep.
Can we see it?
Absolutely. In fact, the way I'm going to doctor this program is to specify something here that is actually more fun. Okay, this is not going to be as much fun, so I'm going to specify something that's a little bit more fun, and I have to remember the ordering of the characters. So I think 4 something starts with the uppercase. So okay, got 4 4 4 3, no 4 5 4 4 4 3 4 2. Okay, and we'll see, find out what it's going to print. Okay. So compile. Holy smokes! It prints, A, B, 0Z, B, C, D, E, the question mark, uppercase S, 2 more back quote, 2 more question marks, and I think that is
Beta sign.
Is it a beta?
Lowercase beta.
Yeah, looks like, well, no, lowercase beta is this. Okay, it's a very strange character. I don't know what it is. And then another, thing. Did I specify those things at all? Actually, I did a little bit. Okay, let's go back to the program. So what we'll do, we'll show the output. I want to be able to show the output and show you the code at the same time. So I can just cap the program because it's a really short program. There you go. Okay, so this is the actual output of the program, and you can recognize the part that we actually specified, right? A, B, 0, Z are in str. Okay, so there's no question about that part. But because in C and C++, whenever you deal with what we call a string, you're only going to specify the beginning. You never specify the number of characters of a string, because the way you know where it ends is by locating the null terminator. So it will keep going until it finds the null terminator. What about that BCDE? Did I specify BCDE? Yeah, exactly. I like that answer. Kind of. Okay. The reason why he said kind of is because 42 in hexadecimal is the ASCII code of B, ASCII code of C, the ASCII code of D, and the ASCII code of E. Okay. In other words, cout, after it has exhausted the 4 characters in str, it just goes to whatever is next to those 4 bytes and say, oh, is that a null terminator? No, I'm going to print it. Is that a null terminator? No, I'm going to print it. Is that a null terminator? I'm going to print it. And it ended up printing out the binary representation of 0x45444342 individually as bytes, and treat it as if, oh, we need to print these bytes to cout. Okay, and that's why I kind of changed my code to have something that is quote unquote somewhat predictable. And guess what? After that, it still cannot find the null terminator, so it continue to print the question mark here, which is corresponding to some kind of non-printable character. Okay. And then the uppercase S, just so happens to be, corresponding to uppercase S, ASCII code, the backtick, and so on. Okay, so this is giving you a pretty good clue of what a overrun condition is. It's basically when you are dealing with a string that is supposed to be null terminated, even after you get up all the way to the end of the allocated part of a string, you still cannot find the null terminator. But anything that is just looking for a null terminator does not know this is time to stop. Okay? In this case, cout doesn't know that string str is an array of 4 characters. So it doesn't know, oh, I will print, A, B, 0, Z, and it's time to stop because the array only has 4 characters. It doesn't know that. It only knows the beginning. So after that, after Z, it will keep going to locate the actual null terminator. Because memory space itself is contiguous. Okay, there are no boxes, okay, per se, to separate one construct, one variable from the next. So it just keeps going. Okay, this is called an overrun condition. Now the overrun condition can be very dangerous because let's think about standards, okay, like JPEG or GIF. Okay, I think GIF is one of the standards. So what I'll do is I switch back to the browser, and we'll just do a little quick lookup of the GIF standard. Okay, Gif File Format. There is a portion of that you can store some kind of text. Some kind of comment, and I'm going to try to locate it quickly. Authentication code. That is a block index 1. I'm trying to find a block where you can store additional information, like maybe not with a GIF. Maybe we can try out JPEG. Okay, there you go. Contains a comment. Text comment, variable size. Okay, these are markers. Okay, I'm not going to spend too much time to look for it, but one of the common graphics file format has a place for you to enter some comments. Okay, so you can enter some text within that portion. And the standard says you can have up to, let's say, 255 characters within that portion. Okay, and it is supposed to be null terminated. So after you type in, oh, this is a picture of grandma's birthday, then it will store that sentence in ASCII code with a null terminator at the end. So you can now imagine something that is supposed to read that particular graphics file format will go to that section and say, okay, I'm expecting a no terminated string here, and it will start to process that no terminated string, okay, to get ready to display it or do whatever it wants to do with it. Is that okay so far? Okay. Now, what if someone is to intentionally specify a string that is up to, let's say, 1024 bytes, but within the 10,024 bytes, there are no null terminators. Okay, so when a program is trying to read in this particular graphic file, it will try to read, and if it's not careful, and it will just make the assumption that there's a null terminator before 255 characters have run out, then it will read in 10,024 bytes, at least 1024 bytes into a place that only has 255 characters allocated. Is that okay? You guys kind of understand what is going on? Okay? And when that happens, we know the first 255 characters are okay because they go into where the array actually has allocated space. What about the other bytes? Where do they go? They're going to corrupt something. Okay? They're going to overrun and overwrite certain portions of memory. And that portion, in most cases, will turn out to be the stack. Okay? How many people have heard of the term stack overrun exploit? Okay, one person has. And you might want to look it up because it's a very interesting thing, you know, stack overrun or stack overflow exploit. And you know, Wikipedia has an entry for that. What I have just talked about is a classic scenario to cause a stack buffer overflow condition to happen. And when that happens, depending on the structure of the program and depending on the skill level of the hacker, it is possible for the hacker to actually gain control over the application because of a stack overflow condition. So it depends on what you are overflowing with. Let's say you have a program that has to run in quote-unquote privileged mode. In other words, it has to run in administrator mode. Some people can craft programs to cause a stack overflow condition to happen when the program is executing in privileged mode. And at that time, what it will do is it will start a shell and do something so that the application or the overrun code, which is also called the payload of the exploit, will now gain control of the computer. For those of you who may not remember, I think Windows had a problem like that once, and I think it's GDI exploit. There we go. It is it's a known problem, kind of in the past. The GDI kernel, the GDI library of the kernel is the one that deals with graphics images, and that is the exact reason why at the time Windows has a real issue because it affected multiple versions of Windows, and in order for a computer to be exploited, to have this exploit to actually work, someone just has to go onto somewhere on the internet to look at an image. That's all it takes for the overrun stack overrun exploit to actually happen, and then the computer is infected. Nobody remembers this at all? 2006, too far ago. Cannot remember anything. No, this is worse than the blue screen of death because this allows people to gain control over your computer. Your computer will join a botnet whether it wants to or not. Okay? All right, so the stuff that we are currently talking about is very important, okay? Because this is how programs get broken, okay? It's not to account for how many bytes we can actually deal with and just blindly look for the null terminator. Are we still doing okay so far? I mean, if I switch back to the program, can everybody see at least why it is not just printing AB0Z? Okay, it's also printing whatever is after that and it won't stop until it finds that null terminator. It just so happens that we're kind of lucky that it finds the null terminator, relatively quickly, because it is possible that it won't find the null terminator for thousands upon thousands upon thousands of bytes. Yep.
If you had not included I, as far as your integer I and I equals,
then I have no control over what is after AB0Z, so I cannot at least show you it will print B, C, D, E all in uppercase.
it would just continue to print anything
Gibberish
until it either does an
until it finds a null terminator.
or a buffer overrun.
No, it will has to find a null terminator. So only two things can happen at that point. It will either have to find a null terminator, but if it cannot find a null terminator before running out of space, then it will cause a segmentation fault because your program will try to read a location that you're not supposed to. But if I don't put in I here, then it is possible that the next byte turns out to be a null terminator, then I won't be able to show you the problem. That's why I put an I here to make sure that the location after the array is non-zero, so that it will keep going at least to print out the B, C, D, E all in uppercase. And it just turns out that even after B, C, D, E as uppercase, there's still some stuff that is non-null before it stops. Okay, all right. So now that we understand the problem with this, let's go ahead and take a look at a string copy. Okay, the typical string copy, and I will just call this overrun2. So I will copy overrun.cpp to overrun2.cpp. So overrun2.cpp kind of goes like this. Okay, so this time I have two arrays, string and let's say string 2, which also has 4 bytes. So this time I want to implement string copy. Okay, so I want to say okay, let's go ahead and copy string to string 2. You specify the destination first, and then you specify the origin, which is string in this case. And we'll call this text string copy, so we are not actually calling the string copy that comes with C and C++. I'm going to implement my own. So I'm not going to return anything. The actual one does return something, but mine does not. Okay. So I'm going to use exactly the same prototype, which means the first one is going to be my destination. The second parameter is const char source, because it is specifying where we are copying from. Now you can see that the two parameters are not symmetric. The first parameter is just a char pointer, and then the second one is a const char pointer. What this does is it tells the compiler, if I try to change what source points to, then the compiler will complain and say this is an error. Because in this case, it's basically saying whatever source points to should be constant, should not change. Is that okay? So if I want to copy from one string to another string, what I need to do is to say, well, let's go ahead and copy first, and then I'll check whether what I just copied is a null terminator or not. Because if it is a null terminator that I just copied, then I can stop. Is that okay? If it is not a null terminator that I have just copied, then I need to go to the next one to keep copying. So I'll show you different versions of this code. I'll start with something that is more spelled out and easier to understand, and then we'll kind of gradually move to one that is a little bit harder to understand, but it kind of tests your knowledge of the increment operators. Okay. Actually, I'm going to use arrays here, so we'll go ahead and use arrays. So we'll start with an index I, and we'll do it the really straightforward way. We'll do it in do while loop. Yeah, we'll do it in the do while loop first. So we'll say do blah 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 while, and I'm going to say as long as what I'm copying is not null, go ahead and go back and do it again. Okay. So what I just copied would be source bracket I, and I'm going to say if it is not null, then I have to do the increment. So I'm going to specify this is kind of obscure too. So I'm just trying to think about. Let's do it this way first, and then I'll explain it. And what I'm doing here is just saying, destination bracket I is source bracket I, like that. So I'll do the copy first, and then I check whether I just copied a 0 or not, or null terminator or not, and increment I, go back and copy again. Okay. I got several questions now, because the first thing that the first question is, destination and source are pointers, but how come I'm using those on line 9 as well as line 11 as if they are arrays? Because the square bracket operator is called the indexing operator. It is basically saying, okay, let's go ahead and access element I of this array. But you can see that on line 3, which is the part that specifies the parameters, I clearly specify that destination is a pointer to a character, and then source is a pointer to constant characters that are not supposed to change. So what is going on here? I seem to be. Yeah, go ahead.
I think you're not using the second array you made, str2.
str2.
Yeah, line 17.
I'm passing as a parameter.
Oh, you're passing.
Yeah, it is passed as a parameter
Okay,
to
yeah.
destination. Okay, but when you look at the subroutine itself, text string copy from line 3 to line 12. I think. Do you think the compiler is going to complain? Because I'm using pointers as if they are arrays.
So that pointer has the same thing as an array?
Exactly. That's what we said last. That's what I said last time, right? In C and C++, a pointer is basically can be considered as an array. So when you specify the asterisk symbol to mean dereferencing, it is almost exactly the same thing as accessing the first element of that array. Okay? Are there any questions? Yep.
So what you told us to not use in our assignment, right?
No, this is what you're supposed to use in your assignment.
I thought that it said, using pointers, you are not allowed to use pointers or pointer dereferencing
Okay, finish the sentence.
to access elements of the array.
Exactly. But I'm not using dereferencing to access elements. So you can see that the elements, or whatever the pointer points to, is accessed using the indexing operator. So this is actually okay. This is actually something that you should do, but your code is not going to be the same, obviously. It's going to be a little bit different. Okay? A little bit different. Okay, now the question is this going to work? And I can tell you that it's not going to work because I++ is not going to work the way it's supposed to. Well, besides, I is not even initialized. So to make this work, I have to make sure that I is initialized to 0 because 0 is the index of the first element of any array. So this will start with the first element of both arrays. It will copy the first element from source to the first element of destination. And then it will check, did I just copy a null terminator? If the answer is no, it is not a null terminator, then it will do the ++i. But the ++i is not going to be a 0 because it is doing the increment first, so it's going to be a 1 by the time we get to it. Yep.
I was just saying that it needs to stop at 4, right?
Hmm?
It needs to stop at 4, right?
It needs to stop at 4? Why?
Wouldn't it keep going?
This will keep going. That's the whole point. It is not right.
Well, there's a problem, right?
Yep. Yep. That's why string copy is problematic. Because by the time you get into the subroutine, it doesn't know the extent of source or destination. It won't stop until it finds a null terminator. Now, if you want to create a scenario where it will never ever stop, is to do what the man page says do not do. Okay? What did the man page say not to do?
Global variable.
Let's read it again. Man string copy, and it told us specifically not to do a single thing. is
Not
right here.
overall.
The strings may not overlap. Okay. Well, what does it mean when it says the strings may not overlap? Okay, that means the source string cannot overlap with the destination string. And then you will think, but how is that possible? Because those two strings or those two arrays of characters are allocated separately, right? So even if you want to, you cannot allocate arrays that are overlapping. Okay, if you say, okay, let's go back to our program. Okay, is everybody okay with this part here? The strings may not overlap? Okay. And if you go back to any program that we have written so far using arrays, it's not possible because the way we declare the two arrays here is they are two different arrays. The first one has 4 characters, the second one also has 4 characters. So the arrays are not overlapping. But what it is talking about is the effect of the copying cannot overlap. Okay? Okay, let's think about what's going to happen here. Let's assume str has an early address and str2 has a later address. Is that okay? So what we want to do is to kind of okay, I'm going to use a spreadsheet for this purpose. Okay, it's going to be helpful for this. Okay, so I'm going to use a spreadsheet because I just need a table, something that has grids. All right, so so I'm going to go from left to right. So this is str, it has 4 bytes. Okay, so this is str bracket 0, str bracket 1, str bracket 2, and each box or each cell represents 1 byte. This is str3. And this is str2, it is declared after str, so I'm kind of assuming that str2 has a higher address. It is after str. So this is str2 bracket 0, str2 bracket 1, str2 bracket 2, and str2 bracket 3. Okay. Nothing is overlapping, right? str is going to take up columns A, B, C, D. str2 is taking up columns E, F, G, H, and they are not overlapping. All right. So now we'll specify the content that we have specified in str, which is A, B, 0, C, Z. Okay. And this 0 is the digit 0, not the value 0. Okay. Okay. So when I have the string copy, the way it is constructed, what is going to happen? Okay. Let me show you the code first. Okay, so that you have an idea of what string copy is supposed to do. It will copy first, right? And then we'll check, did I just copy something that was 0? If it is, okay, let's stop. If it is not 0, this condition is true. Plus I is just one tricky way to increment I, so that by the time I go back to line 10, it's moving on to the next place, the next index. Is that okay? All right. So doesn't seem to be a problem. Okay. But let's see what happens when it encounters a scenario like this, where string is here, string 2 is here, and string does not have a null terminator. Okay. All right. The first iteration will go. We'll copy from str0 to str20, no problem. The second one is going to copy the B to here, not a problem. The third one is going to copy the ASCII code of 0. I should probably use a quote here just to emphasize we're not dealing with the null terminator, but the ASCII code of 0. Okay, the third iteration will copy this. The fourth iteration will copy the Z. Okay, fine. What is the problem? It has not encountered the null terminator. So which column becomes the source in the next iteration? Column E becomes the source of the next iteration. Is that a null terminator? Nope. Okay. Where am I supposed to copy it to? Which column? Column I. Are you guys kind of following this? Because I got 2 fronts going, okay? One front, controls where I'm copying to from. The other one controls where I'm copying to. And as I expand, it keeps overwriting any potential byte that might be a null terminator with something that is non-null. So this will keep going until it crashes until we run out of space to copy. In other words, until we get to a memory location that I'm not supposed to have write access to, then it will try to overwrite that location, and then boom, the program is going to give me a segmentation fault. Okay, but nobody's convinced. Everybody look at this code and go like, nah, that's not what's going to happen. Let's give it a try. Okay, but I do want to show you exactly what's going to go on here, because by the time after the first 4 iterations, which is after we copy this Z into this location, the next location to copy from is now here. Assuming str2 is after str, okay, right after. Then we'll copy this A over here, we'll copy this B over here, and then we'll copy the ASCII code of 0 over here, and then copy the Z over here. And then what happens? The pattern repeats, right? So we'll just be replicating A, B, 0, Z again and again and again and again until we run out of space to do this. Okay? All right. And this is my own string copy, okay? And it will certainly do that, okay? And we can trace it because this is my own code. We can actually go ahead and trace and see what it is really, really doing, okay? Okay, let's go ahead and run this program. G++, this time we do want to get into the debugger, so I'm going to specify -G, -O, overrun2, overrun2.cpp. And let's run it in the debugger first, because I want to show you line by line what a string copy is actually going to do. So put a breakpoint on text string copy. Run the program. And by the way, you can specify a breakpoint using the name of a function, so that's pretty handy. So now we are on the first line of text string copy, and you can see that it is actually doing. It's not going to work. It's not going to work because the source is actually after the destination. So the symptom that I was just describing is not going to happen. It will happen, but it's happening in a different way, in an opposite way. So I'm going to change the program to make sure that it is going to happen the way I described it a little bit earlier, by reversing string 2 and string itself. Okay, so minor change, not really, oops, not that program, 2, there we go. Put a breakpoint at text string copy, run the program. Now we're here, and you can see that the source is having an address of 6.8. The destination is having an address of 6C, so now it is conforming to what we are describing here, where the source, oops, let me scroll back here, where the source is right before the destination. So now I'm recreating the same scenario that I'm talking about a little bit earlier. Is that okay? Okay. Now, something is telling you that something is really wrong already when you just look at this part here. Okay. Does everybody notice, first of all, the source string is not just AB0Z and it's like some gibberish after that. Yeah? Okay. So that means, we are not having a null terminator at the right place. Because if I had a null terminator where this uppercase M is, it will just, stop the double quote at this point and say, okay, this is the content that we're copying. So the fact that it is showing you more than just AB0C is already telling you that something is not right, because we don't have a null terminator where it is supposed to go. Okay. Do you guys see certain things that are in the destination that is a repeat of what the source has? Exactly. Everything after AB0Z, this junk here, is exactly this junk here. Do you think it is coincidental? It's not coincidental at all, because if you look at the location, this is location 6.8, and this is in hexadecimal. This is location 6C. What is C minus 8 in hexadecimal? It is exactly 4. Okay. So what we'll do is now we'll single step through this code. Okay. String copy. Okay. Copy. 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 Okay. So now that we have copy 4 bytes, let's check what is at destination. Okay, check destination has got AB0. Okay, I need one more. I haven't single step yet. Okay, now it's a good time to do it. Okay, so after 4 copies, or after executing line 10 4 times, we have AB0Z here, okay, which is what you would expect, right? Because we are copying from the original string, which has AB0Z, to the destination string, so now that these 4 bytes are here. Let's go ahead and single step 4 more times through line 10. Okay. 1, 2, 3, 4. Okay. Print the destination. What do you think we should see? According to the prediction of the spreadsheet, what should we be seeing here at this point? Yep. We should be seeing 2 repetitions of AB0Z. Okay, so let's double check. And sure enough, that's what we are seeing. So if I do this 4 more times, okay, single step, 1, 2, 3, 4, then we'll see 3 repetitions, right? Sure enough, 3 repetitions. And it seems like this time we have the proper, null terminator. But that null terminator by itself is going to be overwritten by the next write operation, because we keep overwriting the bytes pointed to by destination by something that is non-null. And this will keep going and going. Okay, so I will just kind of show you 4 more times and print destination. Now we have 4 repetitions of AB0Z. And you can kind of imagine that this will keep going like this forever. Okay? And in fact, this is what we'll do. We'll continue execution at full speed and find out what's going to happen. And it says, this is basically GDB's way of saying we have a segmentation fault. Well, okay, it does spell out segmentation fault right here, which means we are now accessing a location that we are not supposed to access. Okay, we have no write permission to that location, and the processor is the one that is actually complaining, because that's the one that is enforcing the boundary of memory locations and saying, oh, you cannot write to this location, and now we have a problem. Okay, how many people think it is just because of the way that I implemented string copy, and the other string copy, the actual string copy, would not have this problem? I think so. This is just a text problem, right? Okay. Well, let's go ahead and see whether that that's going to solve the problem. So when you say man string copy, it's not just showing you how to use a function. It's also showing you, what you need to pound include, the header file that you have to pound include in order to use that function. So now we have to say pound include string.h to get it to work. Get it to compile. So we go back to overrun to .cpp. I don't have to get rid of my own string copy. All I need to do is to change the main so that it will call the other string copy function. So string.h, and this time instead of calling text string copy or text string copy, we'll just use the regular string copy, and maybe this won't cause a problem. Okay. So G++. GDB, and then we just run the program by itself, and guess what? It gives me a segmentation fault anyway. And that's the same problem. It encountered exactly the same problem that we had earlier. Okay. And not sure whether I can, source is not there. Let's try str. Yeah, because it's corresponding to a place that is out of place. Oh, we can do this. We can do a backtrace. See, backtrace is really helpful because we are now at a point where there's no source code corresponding to. And that's why we cannot debug it. It doesn't show any line number because it's not in the subroutine of mine. But I still want to know what is going on with str and str2. And knowing how to use backtrace is really helpful, because backtrace is saying that we are now at frame 0 because that's the reason why we cannot debug it. But if we use frame 1, we are now placing our context back to the main subroutine. Now we have access to str and str2 again. And I'm just going to ask you, what do you think I should see in str2? Just briefly describe it. It doesn't have to be exact. Repetitions of A, B, 0, Z, pretty much the same amount that we saw last time when we were using my version of string copy. Oh, that's not the case. I wonder why. Sorry?
Is it because this is your first run through it with the string copy?
String copy is probably doing something. Okay, let me find out where the address is. The addresses are the same as before, but that's because it knows it doesn't make any sense. Okay, this is what I'll do. Print str2 bracket 4 to force it to print a character, and it is an A. So the only reason why when I print str it is not showing all the other ASDF is because the context, we are now back to the main function, and back to main, the debugger does understand that str and str2 are both arrays of only 4 characters, and that's why it's only printing up to 4. On the other hand, if I cast it to a pointer, then it won't know that it only has 4 characters. Then it will basically it will show the rest. It's the debugger being too smart and say that tag, this is an array of 4 characters, so I will only display up to 4 characters. But once I cast it to a pointer, then we lost the information. Then we would have lost the information about the size or number of elements in the array, and now it's showing me the same thing that we saw last time. And in fact, this ... is saying it's actually more than that, but nonetheless, you get the idea. Are we still doing okay so far? Kind of. Okay. So how do we solve this problem? I mean, this is not a problem that only we encounter in this class because it is, theoretically we can have problems like that. It happens all the time, okay? It happens when people are not careful and just make assumptions, okay? When you look at any type of protocol, okay, you can be looking at this, let's say FTP, okay, as a protocol. You can look at a file format as a quote-unquote protocol. If the protocol says, this portion of the packet can only have up to 255 characters, some programmers will think, okay, now I'm going to allocate a buffer up to 255 characters to store this portion of the packet. That by itself is not a problem. The problem is it's going to copy everything using a null terminated fashion from the original packet into this buffer. That is the problem, because it should have stopped when it runs out of space. Okay? So now we'll go ahead and talk about what is string and copy. And instead of me talking about it, I'm going to use the man page of string and copy, which is actually the same page as string copy. It just has string and copy as a second paragraph to describe it. Okay, string copy function copies the string pointed to by str, including the terminating null byte to the buffer pointed to by destination. The strings may not overlap, and the destination string dest must be large enough to receive the copy. Blah 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 blah. String and copy is similar, except that at most n bytes of source are copied. Okay, now this is the major difference. This is what is going to save the day, is to say, okay, in the case that we cannot find a null terminator, we'll still have a secondary safety net and say, we'll copy only up to this many bytes, even if we cannot find the null terminator. Is that okay? Does everybody understand how string and copy is a safer way to copy a string? Because if the source is longer than the destination, and you specify n to be the size of the destination, it will still stop early enough to avoid problems. Okay? Okay, warning, if there is no null byte amongst the first n bytes of source, the string placed in destination will not be null terminated. Okay? Which is okay. This is kind of what we expect. Okay, we'll only copy up to that many bytes. If we do not copy the null terminator in the process, we do not copy the null terminator in the process. Yes?
But if there's no null terminator in the
destination.
And you can print it out.
Then when we print it out, we'll still have a problem, but at least we won't be corrupting memory. When you're printing, you're for the most part just accessing, you're reading, but you're not overwriting. If the length of st source is less than n, string copy writes additional null bytes to destination to ensure that a total of n bytes are written. So this is also important. So we'll now go ahead and implement string n copy instead of just string copy. And I should probably rename this because we're not going to overrun anymore. So we'll just rename this one as string n copy.cpp, or copy as a new version, new program. Okay, so I'll just go ahead and change this one so that this becomes string n copy, which needs to have the length or n specified here. All right, so what do I need to modify here? Okay, so we have to change the way we exit the loop for sure. Okay, we have to integrate n somewhere into this program. Okay, let's take a look at what we need to do here. All right, and I'm going to change. I'll just go ahead and start from scratch here. All right, so we are now dealing with string n copy, and according to the documentation, it means that we can only copy up to n even if we don't see the null terminator. If we do see the null terminator, we do not stop until we have copied up to n characters into the destination. Yep.
You have to change the. I was just saying you have to change the function call on the line.
Change the function call. Yeah, we have to do that afterwards. Yes. But the first thing we do is to write the subroutine first, and then we'll change the call to the subroutine. Okay. This time I can actually use the for loop. Okay. So I'm going to say start with 0 in I. And I'm going to say as long as I is less than n, do the following. And after each iteration, add 1 to I. So this is right away telling you that I'm going to copy exactly n characters into the destination, even if the source is less than n. It is less than even if the length of the source is less than n. I will still be copying n characters, or it will go through n iterations. Is that okay? All right, so what we'll do next is to say, all right, so what do we need to do here? I cannot just straight away do a copy, and so what I need to do is to find out whether I have seen the end of the source, because that would help me determine which way to go. So I will use another variable here, and of source. Okay, it's just a Boolean. I just need to know whether we have seen it or not. So the initialization is to say end of source is false. We have not seen the end of the source string. And so right here, it's going to say if not end of source, we have not seen the end of the source code, the source string. We'll go ahead and do this. Otherwise, we'll do something else. Okay, let's deal with the something else first. The something else is basically saying we have seen the end of the source string. So if we have seen the end of the source string and we're still copying into the destination, we'll just be getting the null bytes. Okay, we'll just basically be filling up the rest of the destination with the null terminator. So that means destination bracket I, which controls which element we're copying it into, is always going to get a 0 in this condition. This one, on the other hand, is saying that we are still copying something from the source string. So that means the destination string is getting something from the source string at position I as an index. However, we have to now determine whether we have seen the end of the source or not. So there are two things we have to use here to determine whether, only one to determine whether we have seen the end of the source string. Because we can say if the source string at location I or element I is a null terminator, then we have now seen the end of the source string. So the end of source is now a non-zero. You can say a 1, 2, 3, -5, they're all the same because we just need something that is non-zero. Are there any questions about this implementation of string and copy? Okay. Fairly straightforward. I would not call this the quickest way to do it, but it is one way to do it. Are we still doing okay so far with string and copy, the logic of that? Okay. So now we have to change the way we call the subroutine, so that in here, so now instead of string copy, which definitely causes problem, we'll now have tag string and copy, and then we specify the number of bytes that we have allocated to the source or the destination. Well, actually, it should be the destination, but they're the same. Now this is a good time to show you what is size of. Size of is an operator. It tells you the number of bytes that is allocated to a certain thing. So whatever you put in the parentheses after size of is the thing that it will report back on. So in this case, it's telling us how many bytes are in str2, and that becomes the limit, okay? Because we don't want to copy any more bytes than str2 is allocated. Are we doing okay so far with this code?
Would you want str or just str?
Say again?
Would you want str the original?
I'm going to use str2 because it's the size of the destination that matters. In the case that str and str2 are different in terms of sizes, I don't really care so much about the size of the source because I don't want to overwrite the destination. So the source can be a lot larger than the destination. It doesn't matter to me. It can be a lot smaller also, and it doesn't matter to me either. I just want to make sure that I don't overwrite anything as far as the destination is concerned. So that's why we only really need to know the size of the destination and not so much the source. Okay. But when we print it out, it will still print out wrong because the null terminator is still not there. Okay. But it won't cause the problem of a segmentation fault. All right, so let's go ahead and compile this one. It is string and copies. String and copy.cpp, and run it. And you can see that it is still problematic because it is still printing AB0Z twice, and then some gibberish after that. The reason why it's printing it twice, I think we're printing the wrong one. We should be printing the destination, which only should print AB0Z exactly once. So let's recompile and run it again. So it's still printing something that doesn't seem to be right because the null terminator is still missing. Okay, we still have not specified the null terminator, but it's not causing problems. At least it's not giving us a segmentation fault. All right. Are there any questions about string copy, string and copy, and how to access individual components, even though you're given a pointer? Because a pointer and an array are basically the same thing in C++ and C. Yep. Question?
I had a question.
Yeah, I thought so.
With the homework, can we have a 0 for the input? Like you said, you can have up to 80 inputs, and what if there's a 0 in there? You want that not to end the segmentation.
A normal text file will not have a null byte in it, so that should not be a concern.
Well, the other class we were saying that it should be any letters, numbers, anything. So what if one of those numbers is a 0? Wouldn't that just stop the program? Because what if the quit is after the 0?
Are you okay? Let me see if I can understand it. So if you're talking about a test file to test your program, okay, let's say test.in. So we'll give it like this is a test. So this is a regular line. It doesn't have quit in it. So this line will print out exactly backwards, right? It's supposed to print it out as TSET space SI space SIHT. Okay. So are you talking about the line that looks like this?
Well, let's say you had this 0 is test. Wouldn't it stop at, wouldn't it just print SITH? Yeah.
Okay, so this line should be processed just like normal, because this 0 is not a null terminator. This is the digit 0, which has an ASCII code of 48. It doesn't have an ASCII code of 0. So it should not interfere at all with the null termination thing. So when this line prints out, it should be LLL space 0 LLL. And then when you have this line finally, then your program should exit, because this line has just the QUIT by itself. On the other hand, if your line has quitting, then it should print out as GNITTIUQ, because it is not exactly just quit. Then it should still be processed like a normal line.
Oh, I thought the word quit can exist anywhere within the
Nope,
string.
that's not what I don't think that's what the assignment said.
Just the word quit just by itself.
Yep, just the word by itself. That's the only indication that you should quit. You should exit. Okay, read and process a line until a line only contains the word quit. Yep. So quitting is not just the word quit. It is quit plus ing, TING actually in this case. Yep.
Are we supposed to create quit or just terminate?
Well, it says it's, I guess it's somewhat ambiguous, but you don't process the line that has quit in it.
Okay.
So when you see the line that only has quit in it, and then you just get out. Yeah, you do not print TIUQ as the output of that line. That line is not processed. Right. Yep.
So if the line of string is all continuous without space, and you have I am about to quit, it's going to encounter the QUIT.
But that line does not only contain the word quit, so it would not. It's not an indication that you should stop. Yeah. So this basically, this word here is the key, because it says you only quit if that line spells QUIT all by itself with nothing else.
Okay.
Yep. Any other questions? And we kind of talked about this, how to detect that you have just encountered the word quit. Okay, you have to compare character by character. The comparison symbol does not work on strings. Okay, it does something, but it doesn't do what you think it is doing. Okay, I will just use the remaining 2 minutes to illustrate that point. Okay, so let's switch back to here. Okay, this program is called to quit, and we'll pound include IO stream, and I'll allocate a buffer that is relatively large, 80 bytes. We'll have std_cin.getLine. Then we specify where we are putting the stuff. The number of bytes allocated in buffer, which is 80 itself, or to be better, you can say size of buffer. That works too. And also, what is considered a line feed character, the end of the line, which is 10. Okay. And then in this case, we'll say, okay, if buffer is quit, I'm showing you what does not work, so that you guys won't spend the time to try it.
What if you use single quotes, not double quotes?
Single quote won't work either, because single quote can only be quoting characters, not strings.
Okay.
Okay. So we'll go ahead.
So you're gonna do compare strings function?
Or you can compare single byte, byte by byte. The first one is supposed to be Q. The second one is supposed to be U. I think I demonstrated that code last time.
So we can't use
Previous
string
class.
compare.
Oh, if you want to, sure. Go ahead and use string compare. String compare is fine. Yeah. But I do want to show you that this does not work. Okay, so let's say /to quit, and I can type just QUIT, press the enter key, it does not say let's quit. Okay, okay, hold on a second here. So if it's not working and it's compiling, then what exactly is this doing? What are we actually comparing in this case? Because if this works the way that you wish it worked, then we would have printed let's quit, but it did not. Yep.
Well, wouldn't that be just in the first, in buffer 0? It's looking for that.
Nope. It's not doing a string compare. That much we know for sure. What it is really comparing are the addresses. Because buffer is basically an array, and remember what I said, an array is really the same thing as an address. So buffer is the address of those 80 bytes. What about double quote quit double quote? It is also a string, except this one is initialized and it is nameless. Okay, it doesn't have a name, but it is still an address. So this comparison is comparing the address of these 80 bytes versus the address of some location that is initialized to QUIT. They're not the same, right? They cannot be the same. And as a result, this condition is guaranteed to be false, and as a result, we will never print let's quit. Is that okay? So I'm just trying to save you some time. Don't do this; it won't work. But you can use. Okay, so just to be more complete, string compare is allowed. Okay, you can use string compare or string n compare to be more careful. So these two function calls are allowable in your program, and you can call. You have to do a pound include string.h before you use these functions.
But we cannot use string copy, right?
You can use string copy. It's not going to be helpful because string copy does not do the reversal thing. And as far as I know, there are no C functions to do the string compare and string reverse. So I will be surprised. So that you deserve the points if you can find a C standard library call that would actually do the string reversing. Because I think in the time to search for that function, you'll be done writing one also. All right. So are there any questions about the homework assignment? Because we are not going to meet until Monday, which is our second last class meeting. So after next Monday, there'll be one more, which I will use at least a portion of that will be the practice final exam, and then we'll have the final exam.
On Wednesday?
No, the final exam is on the syllabus. So 17th? Okay, so we'll have our final exam on the 17th, which is exactly 2 weeks from today. Yep.
Can you create a discussion forum?
Sure, I will go ahead and do it. All right. So I'll see you guys next Monday. Have a nice weekend.
Yeah, the homework.
The homework. The homework. I mean, come on. This is not going to be that time consuming. This is an easy one.